Okay, so real quick, number 5 on that Graham's Law worksheet, it says an unknown gas fuses at nitrogen, fuses at 1.9 times faster than an unknown gas. So anytime I'm working a problem like this, it's so easy to make a little math mistake. I tend to reason it out ideal-wise first. So nitrogen is faster. That means this other gas needs to be bigger than nitrogen. So when I'm done, I need to come back and say, okay, is this gas bigger than nitrogen? So we're going to need molar mass stuff. Nitrogen, oh, well, that is dead completely. It's making no colors. Nitrogen is into one of the common mistakes people will make anytime they're dealing with Graham's Law problems or masses and Pivnert problems or whatever. A lot of gases are diatomic, right? H2, O2, N2, Cl2, Br2, I2, F2. A lot of your common gases are, a lot of those Hunkelbriefs are gases. So it comes up quite a bit in problems. So nitrogen is 28.02 grams per mole. We don't know about this unknown gas. I know nitrogen is 1.59 times faster than this unknown gas. So when I go to write my equation, I want to have molar mass of the unknown gas on top. So I'm going to do square root of x here over the square root of 28.02. It can be those two divided first and then square root, or the square root of this divided by the square root of this. Either of those is true when it comes to square roots because of the law of square root mathies or something. I don't know. I know how things work. I don't remember distributive and whatever, right? So then nitrogen's on bottom here, which means nitrogen needs to be on top here. Nitrogen is 1.59 times faster, so I'll put nitrogen in at 1.59 and this other gas in at 1, right? So then we just do some math here. I do 28. I do the square root of 28.02, and then I'm going to multiply both sides by this 28.02 square rooted. So that's 5.3. So I multiply that by 1.59, and so then I have the square root of x equals 8.42. Then to get rid of the square root, we just square both sides, right? So we multiplied both sides by this to get rid of this. The 1's already fine. So then we would have that squared, and that gives us 70.8 grams per mole, right? So we solve for a molar mass there. The second half of that problem is make a good guess at this. If you consult your periodic chart, there's no gases with a molar mass around 70.8. There is chlorine at 35.5, which if you double it is right about 71, right? So probably Cl2 is the gas we're talking about here, because if I double chlorine's molar mass, it's around 70.8. But if you look right around 70, 71, it's like in the metal ranges and stuff. I forget off the top of my head, but it's in that range kind of thing, right? This is also bigger, and we said nitrogen was faster, so that makes sense. Chlorine should be slower. Right, so that's number 5. We'll look at number 6 here in a second. So the thought process for number 6, very, very similar. It tells us about oxygen and an unknown gas again. We're looking for the molar mass of the unknown gas again. This time they tell us this gas is 1.69 times slower than oxygen. So again, it's got to be bigger than oxygen, which is fine. There's lots of gases bigger than oxygen. So again, when I put it together, I'm going to say the thing I want on top. I like to solve for the thing I want being on top. I'm putting the problem together. I'm going to make the problem easy for me to solve, right? So if what I want is the molar mass of my unknown gas, I'll put that on top. I'll put the square root of oxygen on bottom, which means over here, if oxygen was on bottom, oxygen needs to be on top. This gas was slower than oxygen, so that means oxygen's faster. So that's 1.69 for oxygen's speed and 1 for this other gas's speed, right? 1.69 for oxygen. So the other gas is still slower. So it's going to give us the square root of 32 times 1.69, which is 9.16, equals the square root of x. We square both sides, and x is 83.9 grams per mole. So we start looking at molar masses in that range, and if you look, krypton is right in that range. So krypton would be 1.69 times slower than oxygen. This is bigger. That makes sense because this gas was supposed to be slower than oxygen, so it should be bigger. That makes sense. Hopefully that helps. Those Graham's Law problems mathematically are some of the more challenging ones. just because there's this inverse thing, and students tend to sometimes forget to flip-flop them, and students sometimes have a little more trouble solving for square root kinds of things. Remember, when you're solving for those square roots, you can divide first and then square root the whole thing, or you can square root each one of them and then divide, and then divide, square root each one of them first and then divide, or divide and then square root the product of that. It doesn't really matter, but just make sure you're treating those things, not forgetting to square things to get rid of it and that kind of stuff. All right, good luck on the quiz today. Make sure you've done the daily quizzes first. We give you a little while on those daily quizzes in case you get sick or you have something, but get those daily quizzes done first and then get the quiz for today done. We want to be caught up because we're looking at tests next week. So make sure we're getting ourselves ready to go, logging in for some help if we need that. We've got almost everything put in for this gas laws unit. Y'all have done a nice job on keeping up with that. We're proud of that.